Bismillah ar-Rahman ar-Rahim, in the name of God, the most gracious, the most merciful. Welcome to Lady Khadija Radillahu Anha online college live lesson, A-level maths, year 2, pure maths. Today's topic is trig functions, and the aim is to do the whole chapter in a day. We're taking breaks on the hour every hour, so 11 o'clock. We're starting now at 10:30. 11 o'clock, the first break will be just a 5-minute break, and then 12 o'clock, 10-minute break, 1 minute, and then 1 o'clock, 2 o'clock, 3 o'clock. We should be finished by 4 o'clock at the latest, inshallah, God willing. The best thing to do if you want to interact is to join via the Zoom link. You should see the Zoom link in the description. So if you join via the Zoom link, you'll be able to respond to questions much quicker than with the YouTube chat. So the YouTube chat takes a couple of minutes, at least a couple of seconds, sorry, to reach me. So it's not really going to be practical for our interactive lesson to go via the YouTube chat. The Zoom chat is real time and it'll work much quicker. So join via the Zoom lesson and you'll be able to answer questions and hear them as well and in real time. Okay, Bismillah ar-Rahman ar-Rahim. Let's begin with a quick warm-up. It's spot the difference, just to get your minds a bit active. So what's happened is you've got an island on the left and it's been reflected onto the island on the right. Can you spot something that's slightly out of place, something that hasn't been quite reflected as it should be? Give you a few moments to see if you can spot that thing. Good. Good use of the chat box to just type in anything you can see that hasn't been quite reflected as it should have been. Let's see what you've got. The cloud hasn't been reflected properly. Fantastic. Okay, good. You can see that position's not quite right. Okay, there are a couple of things, but we'll move on, inshallah. Okay, just a quick warm up just to make sure that you've got the basics. You've got to look at what you've done at GCSE, maybe the first year of A level. This is definitely GCSE level, and just make sure you're comfortable with these basics because they're gonna just help you with the understanding of what you're gonna cover today. So just take a minute or two, see if you can do 1 divided by 4 over 5, the reciprocal of 5, and the other questions. On the right hand side, SOHCAHTOA, can you remember what that means? That's designed to help you remember something. What is that something? What are those formulas? See if you can take a minute just to do some of those. Okay, just a few more seconds on that warm up. Okay, and hopefully that's enough time to at least have done a couple of them. Well done to Aisha, who's given some of the answers. So let's begin with the first one, 1 divided by 4/5. This is going to come up a bit, so you have to know this properly. Let's just do that on the side here. So we're going to keep and then flip and then change. So the 1 gets kept as it is, and then flipped is the 4/5. That gets flipped to 5/4. And then the divide gets changed to a times. So I'll have 1 times the 5, then that makes 5, and then divided by 4 is just divided by 4. So the reciprocal, so 1 divided by 4/5 just becomes 5/4. There's a very special name given to that kind of question where you're starting with 1 and then you're doing a division, and it's called reciprocal. So we could rewrite this question as work out the reciprocal of 4/5. And the very, very easy way to do it with a fraction is you can see here the top goes to the bottom and the bottom goes to the top. Reciprocal of 5, remember reciprocal just means starting with 1 and then doing a divide on the number you're taking the reciprocal of. So it means 1 divided by 5, which is just 1/5. Reciprocal of 0.2 is 1 divided by 0.2, which is 5. And the reciprocal of 2/3, we'll use the trick, which is the top goes to the bottom goes to the top, so that becomes 3/2. Okay, and to finish with the warm-up, the Sokotoa. You're right, Sokotoa, the individual letters do mean opposite for O, A for adjacent. But adjacent to what? We're talking about a right angle triangle. So we have two angles, one here and one here. We just need to mark one of them. So I've just marked this one theta. I could have marked the other one, but with reference to that angle, we then label the other sides. So we've got the angle which is opposite, sorry, the side which is opposite to that angle. Or opposite means you have to go all the way to the other side of the right angle triangle. That's labeled as opposite, which is O. Then you've got the hypotenuse is the big long one going at an angle. And then you've got the other one, which is next to the angle, next to, another word for next to is adjacent. So that's A. So that's what opposite, adjacent, and hypotenuse mean. But then what about the rest of it? What does the so, the ka, the toa mean? Okay, it's the sine, cos, and tan formulas. So you should remember that sine, cos, and tan. So sine of theta, sine of the angle we're looking at, cos of the angle we're looking at, tan of the angle we're looking at, can be worked out as what it says in the Sokotoa is opposite divided by hypotenuse. And then similar for the other ones. But today I want you to look at it in a different way. I want you to think of the right-hand side as being a division, and the answer to that division is what we're naming on the left-hand side. So when we do opposite divided by hypotenuse, doing the division with those two numbers in that order, we're giving that a name of sine. Adjacent divided by hypotenuse, we're giving that a name of cosine. And then the last one, opposite divided by adjacent, as long as we're doing that division with those two numbers in that order, we're giving it a name of tan, tangent theta. So if you think of these as names, then that means we can stretch ourselves and think of new divisions and new names. So let's put these to the side because they're from GCSE. But let's try to do some different ones. And this is what this chapter is all about. So if you can understand this bit, then you'll do very well, inshallah, in this chapter. So with the first one, we can take the opposite and divide it by the hypotenuse. But what if we do it the other way? Why can't we do it the hypotenuse first? That would give us a new division, a new way of dividing. So we've got hypotenuse divided by the opposite. And just like we had to give the first one a name when it was opposite divided by hypotenuse, then we need to think of a name for this one when we're doing it the other way around, hypotenuse divided by opposite. And the name we're going to give it in this chapter is cosecant. Cosecant. So we'd say the cosecant of theta, written cosec, is equal to hypotenuse over opposite. And notice if you look at the fractions now, hypotenuse over opposite, opposite over hypotenuse, they're just the reciprocals of each other. So that means we could write that cosec theta is really 1 over sine theta. So let me just write that underneath. But we can also say that cosec theta is really, or another way of thinking of it is that it's the reciprocal of sine theta. Okay, back to the new divisions. So we did opposite divided by hypotenuse and then reverse that. How about doing adjacent divided by hypotenuse, but doing it the other way? So let's do hypotenuse first and then divide that by the adjacent. So that gives us a new ratio, a new division. And that means we need a new name. Before we called it cosine, cos, when it was a at the top. Now we've got a at the bottom, h at the top. Let's call it sec theta, secant theta, or sec for short. And again, because we've just done the same division but the other way around, it's a reciprocal. So you think now, you take a look at the first one. If I could write cosec theta as 1 over sine theta, then you tell me, if you can type in, what do you think I can also write sec theta as? The first way is to write it as hypotenuse over adjacent, but if I think it's really the reciprocal of this one, which is cos theta, how can I write another formula for sec theta? Good, fantastic. And okay, so let's write that in. So the question was, if I can write cosec theta as 1 over sine theta, then what about sec theta? How can I rewrite that? Noticing that it's really the reciprocal of cos. And Aisha got it right perfectly, mashallah. So it's sec theta can be written as 1 over cos theta. Okay, just to recap for the person that's just come in, we started with Sokotoa, just remembering what that meant from GCSE, and Aisha correctly said O means opposite, A means adjacent, H means hypotenuse, and then the Sokotoa parts means sine. The sine formula is opposite over hypotenuse. Then you've got the cos and the tan formulas. But then what I wanted you to do today is think of not just these three as being formulas, but think of these as names. That when we do a division with opposite divided by hypotenuse in that particular order, then we're giving that division a name, which is sine theta. So similarly, if we now do a division with these three sides, but in a different order, then that means we can give a new name to the new divisions. So if we take the same two sides, opposite and the hypotenuse, but we do it in the opposite order, hypotenuse divided by the opposite, that gives us a new division. And if we have a new division, then we need to think of a new name. And the new name given to this is cosec theta. Then we took adjacent divided by hypotenuse and we did it the other way around, and we've given that a new name. And for both times we notice that it's just the reciprocal. So we're just taking the same two numbers but dividing them the other way around, and that's called the reciprocal when you do 1 divided by something. So really we can say that cosec theta is just the reciprocal of sine theta because it's the same two sides the other way around. So that's just a recap for benefit of the students that just come in. The next one is tan theta is opposite over adjacent. So let's pick the same two sides, opposite over adjacent, but let's try it the other way around. Let's write a new division with the same two sides, but the other way around. So adjacent on the top, opposite on the bottom. And now we need a new name for this division. So what new name are we going to come up with? This one is a bit easier to remember because at least it contains the same name, tangent. So this one's called cotangent, or cot for short, cot theta. So cot theta is the name given to adjacent over opposite, which was tan theta but the other way around. So now you tell me, what formula can I write for cot theta, just like I wrote a formula for the other two? So it shouldn't be too hard. You've done the first two. So we're calling adjacent over opposite cotangent theta. I need another formula for cot theta. Just a few more seconds to think of it. Okay, and the answer is that because it's the same division but the other way around, it's the reciprocal. So I can say cot theta is really the reciprocal of tan theta, and that's written 1 over tan theta. Okay, these three are the new things you're going to learn in this chapter, that as well as having sine, cos, and tan, we've now got cosec, sec, and cot. And if you ever get stuck, you just rewrite them as sine, cos, or tan. So cosec, just rewrite it as 1 over sine. Sec, write it as 1 over cos. And cot, write it as 1 over tan. Now, let's go back to sine, cos, and tan. And what you notice is that if we take sine, the formula for sine, and the formula for cos, and combine them, we get something very, very special, something that we've seen before. So let's do that down here. So I've got sine theta and cos theta. I know the formula for each one. So why don't I just divide one of them by the other? So let me do sine divided by cos. So that would be the opposite over hypotenuse divided by the adjacent over hypotenuse. And if you can use your knowledge of how to divide fractions and work that out, you should get an answer that looks very, very familiar. So remember, the first one was your sine theta, and I'm dividing that by cos theta. So let me give you a few seconds to work out the answer to that division. Good. Not quite. So here we're gonna keep the first fraction and then flip the second fraction and then do a times instead of the divide. So we will end up with the first fraction the same, the second fraction gets flipped, and then the divide changes to a times. But what you want to spot is, does anything cancel? Yes, the h cancels from both. So you're just left with opposite over adjacent. Opposite over adjacent, haven't you seen that before? Yeah, opposite over adjacent is the answer to tan. So what we can say is that sine, when you take sine, the formula for sine, and you divide it by the formula for cos, you just end up with the formula for tan. So sine divided by cos is equal to tan. That's not new. You should have covered that in year one A level, but let's apply that to what is new. So today you're looking at sec, cosec, and cotangent. How about we take cosec theta and divide it by sec theta? What would that give us? And then once you've done that, go back to what we just did a second ago. Sine theta, we divided by cos theta. Well, let's try it the other way around, like we've done for all the others. Let's try cos theta first, divided by tan. Cos theta divided by tan. Cos theta divided by sine theta. See if you can work out what that would give. Your cos theta is adjacent over hypotenuse. And you're dividing that by sine theta, which is opposite over hypotenuse. Let me give you a minute to see if you can work that out. Okay, still working on it. So again, use the same principle. Keep the first fraction the same, flip the second one, change the divide to a times, and you should end up with this time A at the top and O at the bottom. Now again, that's something you've seen before, not before today, but within today's lesson. A over A is the very last one, which is cotangent. So we can say that if I do cos theta divided by sine theta, then I can also write that as cot theta. And the proof of that, if you ever need to know, is you just take the formula for cosine, divide it by the formula for sine, and then you'll get the formula you'll get A over O, which is the same as the formula for cotangent. Okay, I'm just going to leave the screen on this for a minute because you now need to memorize the bits are in this column here. So the three formulas in red and then the three formulas in blue, you must memorize them by the time of your exam, but just take a minute or two to see if you can memorize them now. Okay, Bismillahirrahmanirrahim. Let's begin with the maths examples. So there will be a couple of examples, and then as long as you're happy with them, you'll be in a position to try some questions yourself. So let's begin with example one. And we're looking at a very, very simple example. You just have, the question is, work out using a calculator the answer to sec or secant of 280 degrees. So this is an example. Don't rush and do it yourself. Just watch for a minute, and then you'll get a few in about 10 minutes to go through once we've covered some more stuff. So secant of 280, sec of 280 degrees. First thing I do is I look at the formulas on the right hand side, and I just remember that sec theta is equal to 1 over cos theta. So then I think, okay, this question is really asking me to do 1, to work out 1 over cos of 280 degrees. So this is in degrees, so then you just grab a calculator and type that in, which I will do in a second. That bit you can try if you've got a calculator with you, just type in what you saw on the screen. Make sure your calculator is in degrees mode because we're going to be using radians sometimes and degrees sometimes. So I'm just going to type in 1 divided by, and then I've got the cosine of 280. On this calculator, I'll type it in slightly different to the way you'll do it, and that'll give me 5.758. Just going to check that on the scientific calculator I've got with me, and that's perfect. The answer needs to be rounded to 3 significant figures normally, so we'll just round that to 5.76. So nothing hard at all if you can remember that sec of an angle just means you've got 1 over cos of that angle. Okay, let's try the next one, which is cot of 115 degrees. So do you remember the formula for cot, what it really means? So let's write this here, that cot theta really means 1 over tan theta. So use that to rewrite the question. Cot of 115 just means I've got 1 over tan 115. So if you type that into your calculator, that'll give you your answer. 1 divided by tan of 115, and that's minus 0.466. Okay, pretty easy stuff to begin with. We are gradually just starting with the easy stuff, so hopefully nothing there that caught you out. If it did, very, very quick to learn. Okay, next one. This time we want similar, but the question says get exact values. So really the on-screen calculator is not going to work. You're going to need a proper scientific calculator for this one. So the question is work out the exact value of sec 210 degrees. So this one, again, start off as normal. Remember that sec is 1 over cos. So this question is really asking you to work out 1 over cos of 210. The exact value doesn't mean you keep on writing lots of decimal places. It means that you need it in surd form. So if you grab your scientific calculator and then type this in exactly, making sure it's in degree mode, your calculator, if it's a good one, will give you the exact answer. If you can try this one and just tell me what you get, just to make sure that I know that you do have a scientific calculator. You are going to need one a lot for this lesson. Okay, give you a few seconds. Let's try to find one. Okay, looks like we have one answer, so let's check this one out. Fantastic, good attempt at writing that. It's minus 2 root 3 over 3 is perfect. Inshallah. So we've got minus 2 root 3 over 3. And that's known as the exact answer. Good. Try the next one. Again, we're looking for the exact value, but this time you're going to have to switch your calculator into radian mode. So you should be able to go into, if you've got a Casio calculator, if you press Shift and then the mode or the setup key, you should be able to choose between degrees and radians. I'm doing that now. For the next one, we need it in radians. So set it into radians, and the question is work out the exact value of cosec, and the angle is 3 pi over 4. So just before you type this into your calculator, you're not going to find a cosec button, so you have to remember, you have to look at the formulas on the right. Remember that cosec is really 1 over sine. So we're going to rewrite this question. It's really asking you to work out 1 over sine of the angle, 3 pi over 4. That's the only thing you need to do. As soon as you've got it into that form, then it's just typing it straight into your calculator. I'll give you a minute to do that now. When you're typing in pi, use the button on your calculator rather than typing it in from memory. Okay, and just type it into the chat box once you're ready with the answer there. Okay, good. It is root 2. Okay, well done. I did say I'll give you a couple to try, so if you can take a few minutes, I'll give you a 5-minute timer. You probably don't need that much, but if you can work out these ones, sec of 100 degrees, cosec of 90 degrees, and cot of 135 degrees. So let's make it 3 questions in 3 minutes. And I'll be back in 3 minutes. Okay, just a few seconds left. Okay, if you have any answers, then please type them in. Otherwise, feel free to check your own answers coming up on the screen right now. Okay, well done on the first one. And there are your answers. Okay, Bismillahirrahmanirrahim. I did promise a 5-minute break at 11 o'clock, which we've just gone over. So let me give you that now. And we'll come back and do some harder stuff. It does get a little bit harder after the break, so make sure you're ready for that, and then we'll keep going until we get the chapter done. Remember, there's a break on the hour for 10 minutes. Okay, see you in 5 minutes, inshallah. Okay, restarting in a few seconds, inshallah. Okay, good. Bismillah ar-Rahman ar-Rahim. In the name of God, the most gracious, the most merciful. If you find you get taken out of the Zoom lesson, then just come back in. In fact, we'll do that now. So I'm just gonna come out of the meeting and then we'll go back into the Zoom meeting straight away because there's a 40-minute limit. Okay, Bismillah ar-Rahman ar-Rahim. So the ones that we've covered so far should be quite simple. We're not covering any new ones, but we have missed two out that we did cover earlier. So let's get them down here because we might need them. So the first one is that we can write tan theta as a combination of sine and cos. So if you remember how that works, you take sine theta and you divide it by the formula for cos theta, and you end up with the formula for tan theta. So we can write an identity which is sine theta over cos theta is equal to tan theta. And then one more is the similar thing but with cotangent theta. That can be rewritten as the other way around, cos theta on the top and sine theta on the bottom. And then one big one that we need to write down, I don't have room for here, is sine squared plus cos squared is equal to 1. That's one you're going to use a lot, so make sure that's written on somewhere in your page because you're going to need it a lot. Okay, let's begin with the really advanced stuff now. So we're going to be using these identities to simplify. So in the first example, and this is just an example, so watch it carefully. You'll get a similar one a bit later to try yourself. But the first example is simplify sine theta times cotangent theta or cot theta times sec theta. Simplify sine theta times cot theta times sec theta. So the way to approach this is really you want to try and get everything in terms of the basics. The basics were sine, cos, and tan. And out of those, if you can just get it down to sine and cos, then that would be perfect. So you're looking through this and you're seeing that, well, sine theta is already in terms of sine theta, but the cot theta, you really want to change this. And so you look at your formulas and you think, well, one formula for cot theta is that I could write it as 1 over tan, but even better would be to write it as cos over sine because you've got sine elsewhere. So you don't want to end up with too many different things. So we can rewrite cot theta as cos theta over sine theta. And then you keep looking through and you come to this one here, sec theta, and you think, okay, how can I rewrite that? I really want to get it down to a sine or a cos. So you look at your formulas, and you've got a formula here for sec theta. It's 1 over cos theta. So you can write the sec theta as 1 over cos theta. Okay, let's rewrite that let's rewrite that neatly. So I've got sine theta first, that stayed untouched. And then I've got times by, and instead of cot theta, I rewrote that as cos over sine. And hopefully you can start to see that things are going to cancel out. But keep writing, don't do the cancelling just yet. And then finally, I've got times by. In the original question, I had sec theta, but I'm going to use instead 1 over cos theta, because that's a formula for sec theta. So I'm going to write as my last fraction 1 over cos theta. And now you've got everything in terms of sine and cos. You want to see, is there anything that cancels out? Because the idea is that things on the top will cancel with things on the bottom. So we've got sine theta here, and then we've got a divide by sine theta here. So that can cancel against each other. Can you spot anything else that's going to cancel? Let me give you a second to look at it. That's fine if you need to leave early, it's recorded. Good. The cos theta can get cancelled because you got a cos theta on the top and the bottom. So all we're left with is the things that get cancelled, that really just means they're cancelling down to 1, because the same thing divided by the same thing is just 1. So all we're left with is 1 times 1 times 1. So that is 1. So the answer to the original question simplifies sine theta, cot theta, sec theta. The answer is just 1. Okay, next one is coming up. Let me see if I can give you a few seconds to look at it, and if you have any ideas of where we might begin on this one. But it is an example, so I'll be doing it with you. So the question is, simplify sine theta cos theta, then in brackets times by sec theta plus cosec theta. So just have a look at that, and if you've got any ideas of which parts we might begin with simplifying. Okay, let's just go through this one by one. So sine theta, that's pretty good to stay as it is. That's the kind of basics that we want to keep everything in. Then we've got cos theta, we'll keep that as well. There's nothing really we need to change about that. Sec theta comes next. Let's change that. What can we change that for? We can change that for 1 over cos theta. In a second, we'll change that to 1 over cos theta. And then we've got plus, and then comes cosec theta. What can we change that for? We can change that for 1 over sine theta. Okay, so let's bring those changes in. We're going to keep the first two. But we're going to bring in, instead of sec theta, I'll have 1 over cos theta. And instead of cosec, I'll have 1 over sine theta. And I'll have the plus in between, but I just need to make a bit of room to be able to bring these in. So let's shift that up a little bit, and this a bit. Good. So now the sec theta can get replaced with 1 over cos theta. And then the cosec theta can get replaced with 1 over sine theta. And now what you've got, keep looking at this, because what you've got are two fractions adding together. And you can't add two fractions unless the denominator is the same. So let's make the denominator the same. Let's bring in whatever we need to bring in to make the denominator the same. First, I'm going to need a bit of room. So to make the denominator the same, I can take the first one and times by sine theta on the top and the bottom. Can you guess what I need to do to the second one to also end up with the same denominator? Okay, the second one I'm going to have to times by on the top and the bottom cos theta. So let's do that. Going to have to squeeze it in. Not much room here, so I'm just going to write it in. So I'll have cos theta on the top and cos theta on the bottom. So now the denominators are the same. I can go ahead and add. So I'll have 1 sine theta added to 1 cos theta as my new fraction. So let's copy this line. So this will stay as it is, but then I'll have the combined fraction, which will have on the top, on the numerator, I'll have 1 sine theta plus 1 cos theta. The 1 doesn't really make any difference, so I can drop that just to make it look easier. So I'll end up with sine theta plus cos theta on the top, and on the bottom you'll have the same denominator we had above, cos theta, sine theta. Okay, so that was a little bit more work to combine it because there was a fraction in there, but now we've combined it. The same principle is, can you see anything that cancels on the top and anything that can cancel on the bottom? Have a careful look. So hopefully you've spotted it. You've got sine theta, cos theta here, and then you've got cos theta, sine theta here. Well, it's really the same thing because 2 times 3, when you multiply 2 times 3 or 3 times 2, the order doesn't matter. So sine theta, cos theta is really the same as cos theta, sine theta. They can cancel. If you're not comfortable with that, you could do it a bit by bit. You could do sine theta cancels with this sine theta, and then this cos theta cancels with this cos theta. So the final answer is sine theta plus cos theta. Okay, any questions on that? Any bits that you want me to just repeat before we move on to some more examples? Okay, that's fine. Okay, excellent, well done. Anything there you want me to go over? No? Good. Okay, so let's clear the screen, and if you're happy with that, you're ready for some more advanced stuff. Next example coming up, inshallah. Okay, this is a bit of a big one, so just take a look to try and take it all in. We have to prove that everything on the left will simplify and just end up with the thing that we have on the right, which is cos cubed theta. So let's begin. In a prove that question, you really want to just kind of take what you're trying to get to and just put it on the side and just keep that in the corner there just for you to try and reach. That's your target you want to reach. But the idea is to take the complicated thing on the left and to try and make it simpler and simpler and simpler until you get to the thing on the right. So because we're going to need, it is quite complicated, we're going to need the room. So it's better just to shift that away and just concentrate on what you're going to change. So let's go through one by one. Cot theta, what can we change that for? Can we leave it as it is? No, we can't leave it as it is because everything we really want to try and get in terms of sine or cos, they're the basics. So cot theta, let's go with the last one, which is cos over sine. So we can replace this one with cos over sine. Take a look at the next bit. So now we've got cosec theta next to it. Well, again, I have to change that. I need to change it into something more basic. So that will be 1 over sine theta. Now take a close look at the first thing on the bottom. Here is a slight problem because it's not just sec theta, it's sec squared theta. So what you have to understand about this is that it really means that it's really sec theta squared. So that little square, you can take that to the end. That's what it really means. It's just an easier way of writing it. It really means that you've got sec theta all squared. And to say if I'm going to write the brackets every single time, then that's why the 2 is brought to the inside like that. But when you're working with it, it's better to put the brackets back in and bring the little power 2 to the outside. So it really means sec theta in brackets squared. Similarly, the cosec squared theta, what are we going to do with that? Similar thing, let's bring the 2 to the outside, the power to the outside, and let's bring brackets in. Okay, that's dealt nicely with the power, but it hasn't changed anything with the sec or the cosec. So we need to go back to our identities here. Remember, sec theta is just 1 over cos theta. So that's what I'm going to have to replace with here. And that'll be put in brackets and squared. The cosec theta, hopefully you're getting the hang of this now, it's going to be replaced with 1 over sine theta. Okay, let's do those replacements and in a neat way. So let's get the text to the top. Okay, the first replacement you remember is cot theta gets changed for cos over sine. So let's do that. So that can come over the cot theta can be replaced with cos theta sine theta over sine theta. Similarly comes the next substitution, cosec theta. We're going to replace for what we said, sine theta. And in between, there's an invisible time sign. So you just got to remember that's what the two fractions are doing to each other, just multiplying. So we've got the 1 over sine theta can now come in and replace the cosec theta. And there's a time sign in between. Okay, before we go to the bottom, let's try and sort the top out. We've got two fractions timesing with each other. So the timesing of fractions is really easy. You just times the top with the top, the bottom with the bottom. So cos theta times 1, that's just going to be cos theta. That's all it's going to be. It's just going to be cos theta. And then the sine theta times sine theta will be sine theta squared. I can write that in two ways. I can write sine theta in brackets and then square it, or I can just use the little cheat method and put the 2 in there. So I'm going to have sine cos on the top and sine squared on the bottom, and that's going to replace my fraction, the two fractions that I'm timesing. So that's the top done. Looking good now, looking like it's hopefully going to cancel with a couple of things later on. Okay, let's turn our attention to the bottom now. So we said we'd replace sec theta with 1 over cos theta. So let's do that. And can you guess what that's going to become in a second when I apply the power to it? So that gets slotted in for the sec theta. And it's going to have brackets around it and a power 2. So let's bring the brackets down. And the square is going to apply to everything. So now, sticking with this, again, I don't want the brackets and the squared. It's easier to just apply the square sign to each bit. So on the top, I've got 1 gets squared, so that'll just stay as 1. And then on the bottom, cos theta will get squared, and that just turns to cos squared theta. So I can apply the power 2 to each bit. 1 squared will just stay as 1, and then cos theta squared will become cos squared theta. And that means the brackets I can get rid of. Think about the next one now. I'm replacing cosec theta. Can you guess what's going to happen there when I do the replacement? So 1 over sine theta comes in for cosec theta. And I need to apply the 2, the power 2, to each bit. So the power 2 will apply to the top and the bottom. So 1 squared will just stay as 1. And then sine theta squared will become sine squared theta. That means I can get rid of the brackets. Okay. Staying on the bottom, now I've got 2 fractions which are being added to each other. So remember, the rule for adding fractions is that they have to have the same common denominator. So I'm going to have to change both of them so they have the same denominator at the bottom. That means the denominator will be a combination of the two. So the first one, I just need to multiply by sine squared theta on the top and the bottom. And on the second one, I need to multiply by cos squared on the top and the bottom. Okay, looking good. Let's make those fractions a little bit bigger, those fraction lines. Okay, now the denominator is the same, so I can go ahead and add them. Just get rid of the 1 because the 1 doesn't make any difference. 1 times anything is just that thing. So I'm going to get rid of the 1. Okay, and then let's go ahead and add these fractions. So on the bottom, I'll have the same thing that I had on the bottom. Sine squared theta, cos squared theta. And on the top, I'll have sine squared theta being added to cos squared theta. So that's what you get when you add those two fractions. So let's put that in the place of what I had. So that can go all the way here and get rid of what I had before. Okay, so now it might look a bit funny. I've got a fraction divided by another fraction. So the best way of doing that is to take that middle divide line and just write it as a normal divide. So really it's cos theta sine squared theta. That's your first fraction. Let's put that first. And then this divide line can just be written as a normal divide. Like this, just your normal divide line. And what are we dividing by? We're dividing by this second fraction here. Okay, good. Do you remember the rules for dividing fractions? Are you confident enough you can apply it here? So the rule is keep the first fraction, flip the second one. So that means the top goes to the bottom and the bottom goes to the top. And the divide changes to a times. Good. Okay, you're probably racing to then times the top and the bottom times the bottom, but hold on. Remember that there's something we can make much simpler. Here we have sine squared theta plus cos squared theta. This is one that I said to you, write down on your paper because you're going to need it a lot. I didn't write it here, so I might as well write it here now. The identity you need to remember is sine squared plus cos squared makes a very simple number, which is 1. It's identical to 1. The 3 lines just mean equal, but it's used for an identity. So this whole thing here, we can just replace with 1. Sine squared plus cos squared is just equal to 1. So now I've got a very simple multiplication to do. Don't need the brackets. You can go ahead and do the multiplication at this stage, but don't. Just take a quick look, and ask yourself, is there anything that you can cancel from the top and the bottom? So you take a look and you type in, is there anything that you can see at the top of one fraction that you also see at the bottom of either the same fraction or the other fraction you're timesing by? Just want to cancel before so that it makes the multiplication much easier. Have you spotted something? Good. Sine squared theta can be cancelled. So that sine squared theta can be cancelled with this sine squared theta. Good. Now that's going to be nice because you're not left with much. So is there anything else you can cancel? It doesn't look like there is, so that's fine. Let's work with what is there. We've got cos theta has to be timesed by cos squared theta and then divided by 1. Well, the divide by 1 doesn't really make a difference, so let's get rid of that. So all I've got to do is try to figure out what would cos theta be times by cos squared theta. Any guesses? Remember, cos theta is really cos theta squared. We can take the power 2 outside of the bracket. And cos theta is really cos theta to the power 1. So this is really like x to the power 1 times x to the power 2. Can you guess what that would be? Okay, if you can do it, that'd be great. Power 3, fantastic, is perfect, mashallah. So I can write the final answer is cos theta to the power 3. At this stage, you want to just check back, and you normally find that you're not quite exactly where you haven't quite exactly reached the exact answer that the question wants. You just need to change it a little, make a couple of little changes. But here we're spot on. The question wanted cos theta cubed, and we've got cos theta cubed. That's brilliant. Mashallah, well done, good. So that was quite a big one. So let's just see if you can repeat that back now because it was a lot. Okay, hopefully you followed it up to about here. We were just substituting in the cosec theta, sec theta, cot theta. Okay, and we got to this stage. So now can you explain what did we do next? Or just write down in the chat box, what did we do next? Something to do with, okay, looks like you got it without my help. Made it 1, fantastic. Sine squared theta plus cos squared theta. As soon as you spot anything like that, as soon as you spot that in one of your answers, you just want to make that equal to 1. So well done, that whole thing became just 1. Good, next. Good, you look for things that cancelled, and we did find something that cancelled, which was the sine squared, well done. And then you're just left with cos theta times cos squared theta, which multiplied quite easily using powers to cos cubed theta. Okay, good. Okay, before we run out of time on this, let's move on swiftly to solving an equation now. Just take a look at the next example. Okay, in this question, we have to solve the equation sec theta is equal to minus 2.5. And the interval that we're looking for is between 0 and 360. So the first thing, as soon as you see a sec or a cosec or a cotangent, just ask yourself, what can I rewrite that as? The sec theta can be rewritten as, if you take a look on your left, on your right hand side, it can be rewritten as 1 over cos theta. So let's put that in now. The good thing about this is that it's in the exact format that you want a trig equation to be, a trigonometry equation, where you've got the sec theta or the sine theta thing equals a number. When we make this swap, then it's not so nice anymore because now I've got an easier trig identity, but trig ratio, but it's now mixed up in a fraction. So now we've got to get rid of this fraction, which isn't hard. We're just going to take the cos theta to the other side times by cos theta, and we're going to divide by the minus 2.5. So that can come here. And this minus can just go at the front. It doesn't have to go on any specific number. So that's a better equation to work with. Let's just reverse that. So I've got the cos theta on this side and the minus 1 over 2.5 on this side. Good. So now it's standard. You're just going to type in inverse cos of minus 1 over 2.5. So just grab your calculator and just, we're working in degrees, so you can stay in degree mode, but we just want minus 1 divided by 2.5. So that's minus 0.4. And I just want to inverse cos that. So there's your first answer for your theta. It's 113.5781. So I can say my first answer for my theta is 113.5781. And now you have to remember that the cosine and the sine graphs, they repeat, they go up and then down and then back up. So you get multiple answers. You get multiple answers because the same horizontal line is going to cut at more than one place. It would maybe cut here, here, and then cut again here. So on a cosine equation, you want to get the second answer by just doing 360, take away your first answer. So let's do that on the calculator. 360 degrees, take away my first answer, and that gives me 246.4218. So that's better. You can't always stop at two answers though. Sometimes you have to get three or four. So what you now do is notice that the curve repeats every 360 degrees. So you just have to take your first answer and add 360 degrees to get a new answer. So let's add 360 to that first answer. Let me type it in, 1.113.5781. Add 360. That'll get me to 473, but that's over the 360, so I don't need to write that one down. These two are enough. Okay, good. There is only 5 minutes, so that should be enough, inshallah. Let's have a look at the next one. We now need to solve cot 2 theta equals 0.6. Can you guess the first step? Welcome back. If you've just joined, we're doing trig equations, and we have to solve cot 2 theta equals 0.6, and we have a time limit of 4 minutes before this session finishes. So we quickly take a look at the right hand side and think, what can I swap cot theta for? Cot theta can be swapped for 1 over tan theta. This is 2 theta, so just make sure you're writing 2 theta when you do that swap. So I can swap that for 1 over tan 2 theta. Let's do that swap. And now I've got 1 over tan 1 over tan 2 theta equals 0.6. So if you were looking at the first equation, can you remember what we did? We don't like to have any fractions here. We just want to make sure it's just something theta equals a number. So the way we do that is we're going to take the tan 2 theta to the other side. That's going to times, and then the 0.6 can come in that space, so it's dividing by 0.6. So that makes it tan 2 theta equals a number. Let's bring this to the right hand side. That's what we're used to seeing. Okay, so we have tan of an angle. It doesn't really matter, it's a 2 theta, but it's tan of an angle is equal to 1 over 0.6. So grab your calculator, type in inverse tan of 1 over 0.6, and that'll give you the answer for 2 theta. Please type in what you get. I'll do it on the screen as well. So I'm doing 1 over 0.6 and inverse tanning that. Should be in degrees mode at this stage. So the answer you get is, first answer you get is 59 something. Good, 59.04. Here we have to keep the numbers as exact as possible, so I'm just going to go with a bit more accuracy, 59.036. You'll see why in a second. Because there's more answers, and we use the first answer to get the second answer. The tan graph, it repeats every 180 degrees. So all I need to do is take my first answer. If I add on 180 degrees, I'll get another answer. And then you just keep doing that a couple of times. So you get 239.036. Do it once more. You get 419.036. Do it once more. How do you know when to stop? You normally look at the range here, and because it's 2 theta, we have to go to double of that. So let's write that one, 419.036. And do it once more. And then now we have to look at the last bit, which I'll leave you to do because this Zoom lesson is about to finish. But these are the answers for 2 theta. We need the answers for just theta. How do we get the answer for theta? Very easy. We just divide everything by 2. So if it was 3 theta, we divide everything by 3. But this is 2 theta. So take each and every answer one by one and just divide each one by 2. I'll do the first one for you. So 59.0362 was the answer for 2, our first answer for 2 theta. Just divide it by 2 and you get 29.518, which I'll just round to 29.5. And you do the rest by dividing by 2. Okay, join me, time for a 10-minute break, and then join me for more in 10 minutes, inshallah. Assalamu alaikum wa rahmatullahi wa barakatuh. Okay, Bismillah ar-Rahman ar-Rahim, starting in a few seconds, inshallah. Bismillah ar-Rahman ar-Rahim, in the name of God, the most gracious, the most merciful. If you're joining via YouTube, then do click on the Zoom link and it'll help you respond and Okay, Bismillah ar-Rahman ar-Rahim. Just a quick recap from last time. So we were solving cot 2 theta equals 0.6. So the first thing we did is try to find a simpler identity. Instead of using cot, we just want to use sine, cos, or tan, even if it's 1 over. Welcome to VJ. So we've got sine, cos, or tan, which are the simpler ones. We always want to try and stick to them. So we've got cot 2 theta. We can swap that for 1 over tan, but just remember to use 2 theta here. So that gets swapped, and then having the tan 2 theta at the bottom of a fraction isn't particularly gonna make things easy. So we just wanna, thanks Aisha, we just wanna swap that around. So we just wanna swap that around. 1 over tan 2 theta can be swapped for, bring the tan 2 theta to the right, bring the 0.6 to the left, and that's a much easier way to do that. Did anyone remember what we did after this? We've got tan 2 theta equals 1 over 0.6. Something to do with your calculator. Okay, hopefully you'll remember that we just put that into the calculator as an inverse tan. So we're typing in inverse tan of 1 over 0.6. That gives us the first answer. So that's a very, very easy one. And a lot of students, they'll just stop there. But the question said it wants the complete set of answers in the range 0 to 360. So then what did you do? Do you remember how to get to the next answer? If so, just type it into your chat box. That was a bit of hilarious intercession there. So we've got the next answer, 59.0362. To get to the next answer, we just want to add 180. And we can keep doing that. And that gives us a nice set of answers for 2 theta. But how do we get the answers for just theta? And the answer would be just divide by 2. So that gives us the range of answers. Good. So that was a recap because I think you're going to need it. The next session, the next little slot is for you to try some of the questions yourself. So I'll be here to help you if you need a bit of help, but let's see how you get on. I'm going to write a couple of questions for you. Welcome, Amir, to the session. So first question is coming up. Just give me a second. Okay, so when you're ready, have a go at this one. And if you get stuck, then I'll help you. But let me give you a bit of time to try it yourself. So the first one is simplify sine theta cot theta. And the second one is prove cos theta plus sine theta tan theta equals sec theta. And then the last one for you to try is solve sec theta equals root 2. So based on what you've seen today, have a go. You've got the identities on the right, and then I'll rejoin you in about 3 minutes. Okay, welcome to Ahmed who's just joined. Just working through the 3 questions on the screen. Okay, don't know if you need a bit more time, but just let me give you one more minute to try these. Okay, just a few more seconds to see if you can do at least one of them, inshallah. Okay, let me know if you need a bit more time or if you've made an attempt and you can't get further or you've answered all of them. That's fine as well, but just let me know, do you need more time? Just yes or no in the chat box would be great. Okay, so more time, yeah, that's fine. Just take another minute because we were rudely interrupted. I think the first person might have been genuine. After that, definitely two were not genuine. So we have Abdul and Chia. Okay, Aisha, you said you don't need any more time, so if you can not write your answers into the chat box, but if you can just tell me for questions 1, 2, and 3, whether you were okay on them or not. The reason, sorry, the way to do that is just write a little color. Just write a color next to each question number. So write question number 1, just write the number 1, and then just put R for red or G for green, or amber is in between, and then do the same question number 2, and then question number 3. Just so I know if you're stuck on all of them, then I can explain the basics again. Mm. Okay, just take a minute, take a couple more minutes then. There's no point in attending a full day session if you can't do the answers if you can't do the questions at the end of it. So you have to be able to do the questions. This is the key bit. So if you're getting it wrong, that means we need to just go back a couple of steps. Okay, just 10 more seconds and then we'll go through these, inshallah. Okay, if you can just, you should know whether you got the first two right. No, actually, number two, you should know whether you got right. The number one and number three, you won't know until I give you the answers. But just tell me about how you're feeling about the question. So write the write the numbers one, two, and three, and just put a color next to each one, green or red or amber. Okay, sorry to keep you waiting. Let's go through them now, inshallah. Let me just check what you wrote. Okay, amber, green, green, and then amber and green. Okay, so it looks like you got the basics. So, inshallah, let's go through this quite quickly. So, first one, simplify sine theta over sine theta times cot theta. So, hopefully, you're remembering that cot theta can be rewritten, but you don't really want to choose 1 over tan theta, because if you choose 1 over tan theta, you will still end up with two different trig ratios. You still end up with sine theta, which is different to tan theta. They don't really work together. They're quite different to each other. So you want to choose a different one. So which one do you want to go for? You want to choose this one, cos over sine. So cot theta can be replaced with cos over sine theta. And that'll make something very easy for you. Aisha, can you tell me what, if you're confident enough, tell me what happens next? You did see it in the example. We got sine theta times cos theta over sine theta. I think you said you were a bit unsure. No, so Mu'mina was a bit, both of you are a bit unsure on number one. So good, you cancel sine theta, cancels on the top and the bottom. So you're just left with cos theta, so that's your answer for number one, cos theta. Okay, next one is more like the kind of questions you're going to get in the exam. So let's take a good look at this one. We want to prove cos theta plus sine theta tan theta equals sec theta. So take the equals sec theta away. That's going to distract you. Just that's what you want to end up with. But this is what you're going to work on. So now take a quick look and see which bits can you keep the same, which bits are you going to have to be different. Cos theta is fine. That's one of the basics, sine and cos, or tan even. Sine theta again pops up and that's fine as well. We can keep that as it is. Tan theta is one of the basics, but it's better to get everything in terms of sine and cos if you've already got sine and cos elsewhere. So tan theta has to go. What are we going to replace it with? Good, well done. Sine theta over cos theta. So let's get that swapped. And now normally we're looking for something that cancels. Here we're not that fortunate, so it's not going to cancel, but we can do the multiplication. So if we put sine theta over 1 is being times by sine theta cos theta, then we can combine those two fractions into 1. So you should end up with, on the top, sine theta times sine theta is just going to become sine theta squared. And on the bottom, have a look and tell me what that's going to become. So not much there. 1 times cos theta is just going to be cos theta. Good so far, but now it looks like you're a bit stuck because there's nothing else you can change. The sines and the causes, they're all there, and they're not really cancelling with each other. So what you have to do here is just add the two fractions. The two fractions, we only really have one fraction, but we can make this the first one a fraction as well and just put over 1. And now we want to get the same denominator. So what's the denominator going to be? This one's got cos theta, so we just want to have cos theta here as well. So that means I'm going to have to times the top and the bottom by cos theta. The 1 will just become a cos theta. And if I times the top by cos theta, I've already got cos theta here, so that just means I get cos theta squared. Okay, now the two fractions can be added. So on the top, you've got cos squared plus sine squared. Easier to say sine squared plus cos squared. And then on the bottom, you just keep whatever is there, which is cos theta. Okay, looking good. From there, you tell me what happened next. Okay, good. Sine theta, sine squared plus cos theta, sine squared plus cos squared can be written as 1. So you end up with 1 over cos theta. That's about as simple as you can get it. So then take a sneak look at the answer you're trying to get to. And we're not quite there, so just think 1 over cos theta. How can I turn that into sec theta? And the answer is we just use the identity we were learning at the beginning. The 1 over cos theta can be rewritten as sec theta. Okay, anything there that you got stuck on or you want to just go over again? Are you happy with that? Okay, both of you hopefully happy. So just tell me what happened next after this step. Cos theta plus sine squared theta over cos theta. What did I do next? Because at the moment it looks like nothing really is going to cancel. Okay, good. You turn it into a fraction. So it's cos theta over 1. That's a fraction, add another fraction. Make the denominators the same by timesing the first one by cos theta on the top and the bottom. And then you can go ahead and add the fractions and then simplify. And you get sec theta. Fantastic. That's good work, mashallah. Okay, last one, if it's still there on the screen. Okay, this one, the equation. I didn't put the range, but just assume 0 to 360 degrees is the range. So here, first thing is the sec theta has to be swapped. It's going to be swapped for 1 over cos theta. Then do a bit of rearranging and tell me what does the final equation look like. You should end up with, from this position, you want to make it look like cos theta equals something. So to get rid of the fraction, let's take it over here and then bring the root 2 across. Okay, 1 over root 2 is perfect. Good. Well done to Aisha and Mu'mina. Inshallah, Sannan. Inverse that, inverse cos 1 over root 2, and what's the first angle you're going to get? What's your theta going to be to begin with? Just type it into your calculator if you didn't get a chance before. Good, 45 degrees. So now to get the second and the third and the fourth, you just have to take it easy. You want to get the second one by doing 360, take away the first one. So that makes 315. Then you have to start back at the beginning and just keep adding 360 to each one if you need to. So if you do 45 at 360, that'll tell you the next one is 405, but we don't need to write that down because we're already at the 360 limit. So that's perfect, mashallah, well done. Good work on that, mashallah. Confident that you've picked up the main bits you need. Okay, let's take a look at the next bit. Okay, good. So sine squared plus cos squared theta is 1. We are going to transform this to make it look like something completely different. And you're going to have to memorize that new thing. So it's not too hard to transform it, which is good because if you're ever stuck in the exam, you can just follow this step. So what we're going to do is we're going to divide through, that means divide every single bit of it by sine theta. Why sine theta, not cos or tan? Actually, you can do it by all of them, and you're gonna do it by at least two of them in the next 10 minutes. So whichever one we're gonna do, it doesn't really matter which one we do first. So let's just divide by, let's just choose sine first. So I'm gonna divide every single part of it by sine theta. So sine squared theta gets divided by sine theta. Then the cos squared theta gets divided by sine theta. And then the then the 1 gets divided by sine theta. And now we look at each part and think, okay, can we simplify it in any way? We've got sine squared theta over sine theta. Have a good think. What can that simplify to? Okay, I'm just checking I've done this right actually, but I think so. Okay, good. So that can be simplified to sine theta because the squares would drop off. Okay, good. Okay, the next one, we've got cos squared theta over sine theta. Okay, I noticed the mistake I made. Okay, let's just go back one step. So we divided by sine theta. We want to go one step further. We don't want to just divide by sine theta, but we want to divide by sine squared theta. That way, the first fraction will simplify much better. So let's just repeat that. Sine squared theta, we're dividing through and dividing through again. Okay, now that should work out much better. So the first fraction, take a good look at that, sine squared theta over sine squared theta. That simplifies to something very, very easy, which is, let me know if you can spot it. Okay, good, that will work out much better. So that just becomes 1. Then we've got the plus, and then cos squared theta over sine squared theta. Take a look at one of the ones we had down here. That's very similar to this. So if cos squared theta over sine squared theta is what we've got, then that's going to simplify to cot squared theta. And then the final bit, what will 1 over sine squared theta simplify to? The clue is this one. And hopefully you've got it. It's cosec squared theta. Okay, that means that's your new identity that you're going to have to memorize, and we're going to have to use quite a lot. So let's just have that in the corner here. Okay, good. Let's repeat, but this time we're going to divide by something else. So we're starting with the same sine squared plus cos squared, but this time we're going to divide by cos squared. See if you can figure out what we're going to end up with. Okay, ready? The first term is sine squared over cos squared. What will that simplify to? Have a think. Very good, mashallah. Tan squared is correct. And keep going. The next one. Okay, very good. Next one is a very easy one. That's going to become just 1. So well done. If you've got 1 there, well done. And then the last bit, what is that going to simplify to? Let's take a quick look. We're looking for 1 over cos, which is this one. So something like sec squared. Well done. Sec squared theta. Good. So these identities are really what makes second year A-level questions second year A-level, because these ones are quite hard to stick in your head and to understand where they come from. But hopefully you've got at least the main part of them. Let's stick that second one here. So sometimes you'll need the first one, sometimes you'll need the second one. Sometimes you won't need either of them. It'll just be the very basic sine squared plus cos squared equals 1. So it's worth having that there as well. Okay, let's try and use this. Next example coming up where we're going to have to use this. Okay, prove. Okay, take a good look at this one. This one is a real second year A-level question. Prove cosec to the power 4 theta minus cot to the power 4 theta is equal to 1 plus cos squared theta over 1 minus cos squared theta. So as with the previous ones, what we're trying to get to, let's just keep that in a corner somewhere. And let's work on the main bit, which is this bit here. And it might look like there's nothing really we can work on here. But what you notice is that this is the difference of two squares in disguise. Difference of two squares you've come across a lot at GCSE. So if I had something like 100 take away x squared and you were doing factorizing, do you remember how that would factorize? You end up with two brackets. Each bracket has almost the same thing except one is plus, one is minus. In this case, you'd have 10 minus x and then 10 and x, but with a plus in between in the second bracket. So that's called the difference of two squares because each one is a square number or is a power of 2. But any even power will do the same. So power of 4, I could have had power of 4 as my x squared. And then to make the power of 4, I would have had x squared and x squared instead of just the x. So that's the kind of thing we want to use here. It's a takeaway in the middle, so that's your first sign is the difference of two squares. And then we've got an even power. So that's those two things tell you or give you good indication that we're looking at the difference of two squares. So how will that read in each bracket? The first bracket will have cosec theta but to the power of 2. Can you guess what's going to be coming after that? Okay, it's going to be plus and then cot theta. Again, the cot theta is going to have a power of 2. Okay, and then if that's the first bracket, then the second bracket is going to be exactly the same, but with a minus in between. Okay, let's put the minus in between. And now try to use what you just learned, the new identities. 1 plus cot squared equals cosec squared. Is there any place where we can use that? Tan squared plus 1 is equal to sec squared. Is there any place where we can use that? So probably not the second one, but the first one you should be able to spot. So sec squared theta, cosec squared theta. If you can spot that in this question, we can swap that for a 1 minus cot squared. So let's do that here. And then what you'll see is that I've got 1 plus cot squared theta, but then I've got take away cot squared theta as well immediately after it. So that means that will disappear. So I'm just left with 1. And timesing 1, I don't really need to do anything there, so that can just disappear. So now it's reduced to cosec squared theta plus cot squared theta. Okay, next step, see if you can figure out what to do here. Remember, we're trying to get it to end up as 1 plus cos squared. Okay, then it's just back to basics, but what we did before. So cosec can be rewritten as 1 over sine. So cosec squared can be rewritten as 1 over sine squared. And that's something you've seen a couple of times already, so you shouldn't be um, too worried about that. 1 over sine squared theta. Okay, what about the second one? What can we swap cot squared theta for? I'm going to give you a few seconds. I want to see if you can answer this one. Okay, looks like we have an answer. Just give you a few more seconds if you need it. Good. 1 over tan squared is one possible. I don't think it. Yeah, you're right. So cot theta is 1 over tan theta. So exactly, cot squared could be really written as 1 over tan squared. But think again, because we don't want to end up with too many different things. If we got sine and a cos and a sine and a cos we can kind of handle, but sine and tan, cos and tan, they don't really. We want to avoid tan if we've already got a sine and a cos. Okay, so cos squared over sine squared. Good. That's going to be the better one because we want it to be able to cancel with the sine squared somehow. So it's better to have everything in terms of cos and sine. So we can write that as cos squared theta over sine squared theta. Well done for spotting that. Okay, and then have a think. What can we do to try and get something to simplify here? Okay, two fractions, but actually it's very easy. You should be able to spot the next step now. No, not quite spotting it. Okay, take a look. When you have two fractions, you want to add the two fractions only if the denominator is the same. And actually, it is the same. So we can go ahead and add those two fractions. So we would have on the top plus the top would be 1 plus cos squared theta. And on the bottom, it would just stay as sine squared theta. And now when you see 1 plus cos squared theta, and then you've got sine squared theta on the bottom, remember that either one of them can be changed using the sine squared plus cos squared is one identity. Which one we're going to change really depends on what we're trying to aim to get. So now is a good time to take a look. Go back to what the question was. And if you see right in the corner here, we've got 1 plus cos squared theta on the top, which we already have. And on the bottom, it's 1 minus cos squared theta. So it's the bottom one that we need to change. So think about it. Sine squared plus cos squared equals 1. If I rearrange that, I can take the cos squared over here. So I'll end up with take the cos squared across, and it'll become a minus cos squared on the other side. Just need to make a bit of room. So minus cos squared as it comes over from being a plus cos squared. And that's it. That's the only substitution you need to do now, is we can swap this sine squared theta at the bottom for the 1 minus cos squared here. Okay, and that's the question done. That's what we're trying to prove. So that's it. Good. Let's see how much of that you managed to follow. Okay, I'll pause it and then you have to tell me the next step. So we reached this. We started with cosec to the power 4 theta minus cot to the power 4 theta. We used the difference of two squares, and then we very cleverly put in, instead of the cosec that was here, we swapped that for the 1 plus cot squared theta. Okay, tell me what came next, what happened next. to simplify this. Okay, what happens next? Second bracket simplifies to 1. Fantastic, mashallah, so that's good. Second bracket simplifies to 1. Timesing by 1 doesn't make any difference. So now we're down to cosec squared theta plus cot squared theta. Now what do we do? Or what did we do? Okay, good. Substitute it with what we've been learning on the right hand side. So the cosec squared got swapped for 1 over sine squared theta. The second one was a bit of a harder one. Do you remember what we ended up swapping that for? So with the cot squared theta, what did we end up swapping that for? Okay, if you're not sure, it was cos over sine, cos squared over sine squared theta. Good. Next. Fantastic. There are two fractions, they're ready to add because the denominator is the same already. So nothing difficult there, just add the two fractions, add the top, and you get 1 plus cos squared theta on the top, sine squared theta on the bottom. Remember we were trying to get to this, so then the top already matches, but then how do we get the bottom? What do we do with the bottom bit? Fantastic. You use that sine squared plus cos squared, rearrange that for sine squared and put that in. So we get 1 minus cos squared there instead. Good. Okay, well done for following that. Mashallah. More to come, but let me give you a 10-minute break. Actually, got to pray Zahar as well, so let's make it a 20-minute break and I'll join back at 1:15, inshallah. Assalamu alaikum wa rahmatullahi wa barakatuh. Okay, Bismillahirrahmanirrahim. Lesson's about to start in a few seconds, inshallah. Okay, Bismillahirrahmanirrahim. In the name of God, the most gracious, the most merciful. Well done for learning what you have learned so far. Let's continue with the next example. This one is a little bit different to the rest. So the question is, the tan of an angle is equal to minus 5 over 12 Based on that, can you work out sec of the angle, and then after that, the sine of the angle? So let's do the first one with sec. So what we want to try and do is use the identities that we've learned so far, and just try and spot the one that's got something like tan or sec in it. So we've got here this one, tan squared theta plus 1 is equal to sec squared theta. So that looks like a pretty good one to use. So let's grab that. Okay, and tan A is equal to minus 5 over 12. So where we've got in the identity tan squared theta, then if I've got tan A, then is minus 5 over 12. To get tan squared, then I would just square it. So I could replace tan squared theta for minus 5 over 12, but squared. Okay, when you're squaring a negative number, a negative times a negative makes a positive, so that's going to disappear. And then 5, then applying the square to the 5 and the 12 would become 5 squared on the top, 12 squared on the bottom. So you would just end up with 25 over 144. So that's what we can have on the left-hand side. I want to try and get to sec squared theta. So having the plus 1 there isn't really helpful. Before I can square root, I need to try and get this into one fraction. So I can write the 1 as 144 over 144. That will allow me to add the two fractions. So on the top, I'll get 25 plus 144, so that's 169. And then on the bottom, I'll still have 144. So I can write that as 169 over 144. Now I'm in a position to square root both sides. So if I square root both sides, then the square root and the square sign here will cancel out. And on the left, I've got the square root of each one, which each one is a square number. So I'll have 13 over 12. But remember, square roots have two answers, a positive and a negative. So you just need to remember that and put that into your answer. The way you do that is you just put plus and minus at the front. Okay, let's just go over that to see how much of that you managed to catch. We're trying to solve We're actually not trying to solve an equation here. We're trying to use, based on an answer that we're given for tan, we're trying to get an answer for the same angle, but for the secant of that angle. So do you remember, what do we start with? If so, please type into the chat box. Okay, the thing we're trying to get is a sec of the angle, and the thing we've got is tan of the angle. So we're just looking for an identity that's got the sec and the tan in it. So the one we find is the middle one just here. So we pull that to the side, and then we substitute in. If we know what the tan is, then we can get tan squared quite easily by just squaring the 5/12, the minus 5/12. Do you remember what we did from there? Okay, then it's just to square the fraction. That made 25/144. And then before we can start square rooting, we want to really get the fraction and the number together so that the 1 can be written as 144/144. Then we can bring that together, and now we can do the square rooting. So we end up with sec theta is equal to plus or minus 13/12. Good. Okay, if that was a little bit new to you and you weren't quite sure how to do each step, that's fine. But now the second one should be easier because you've seen the first one. So now the second one is to work out, based on tan of the angle is minus 5/12, to work out sine of the angle. So see if you can figure out, good. See if you can figure out what we're going to do to start this one off. We want to try and get the sine of the angle based on tan of the angle. So start looking for the identity. We want to try and get one which has got a sine and tan in. And that's the one here, the tan theta equals sine over cos. Okay, how are we going to use that? Tan theta, we already know what tan theta is. It's minus 5/12, so I can use minus 5/12. And now I'm a little bit stuck because I've got sine and cos, but it doesn't matter, just carry on. We want sine theta on its own, so let's take the cos theta onto the other side. So that would mean we can take this onto the other side here. So now I've got an expression for sine of the angle. But now you're really going to have to think about the next bit. Is cos theta, we don't have anything for that, do we? Or do we? Really, we want a fraction here. We want an answer for cos theta. We've only been given an answer for tan. We're trying to get one for sine, but we've got this cos theta in the way. So the clue is what we did before. We got sec, the sec of the angle. We worked that out. If you remember, it was plus or minus 13/12. How can we use that to be able to fill in something for cos theta? Really think, give it a good think now. Good. We can use the reciprocal, but reciprocal of what? Let's take a look on the left-hand side. We can see that cos theta, 1 over cos theta, is equal to sec theta. So let's try and use that. So on the side, we can see that 1 over cos theta is equal to sec theta. In this question, we can ignore the plus version of it, and we can just use the minus version. I'll have to do that in a separate lesson, but just go with, we know that sec of the angle is minus 13 over 12, so let's replace minus 13 over 12 instead of sec theta. And as Aisha said, we can take the reciprocal of this, and that would tell us what cos theta is. So taking the reciprocal of both sides, cos theta would be equal to minus 12 over 13. That's one way of doing it. Another way of doing it is just to rearrange it. If you're comfortable rearranging formulas, then it should be quite easy just to take the cos theta to this side, take the 12 onto that side, and then the minus 13 can go onto this side. So either way, you end up with a fraction for cos theta, and that fraction can go here. So we can work out what sine theta is based on sine A just by multiplying those two fractions together. So if you can do that and then tell me what the answer is. Okay, good. Okay, very, very easy to just cross off the 12s because they cancel and you're just left with 5 over 13. If you've got that, well done. Okay, a couple of tricky bits there that I hesitated on, so let me just make sure that you understood what to do at those points. Let me get to the point here. So we've got minus 5 over 12 times cos theta equals sine theta. We're trying to get sine theta, so we don't want to get rid of that. But how do we get rid of the cos theta? Do you remember? Something to do with our answer from before for the first part, which was getting sec of the angle as plus or minus 13 over 12. Okay, good. We did use the reciprocal, so we used the identity first that sec over the angle is equal to 1 over cos. We filled in the sec A part, the sec theta part, by using the answer from before, and then we either rearrange or take the reciprocal to get a value for cos theta, which is minus 12 over 13, and then that can get substituted in, multiplied together, and you end up with 5 over 13. Good. Okay, this is the last one before you get to have a go yourself at a couple of questions. So this is the last example, so watch carefully. We have sec squared theta minus cos squared theta. And we have to prove that that is equal to sine squared theta, then in times in brackets 1 plus sec squared theta. Okay, let's begin. Normally we take one of the sides and just put them away. This time we're going to take this side on the left. Just put that away. That's what we want to try and end up with. What we're going to work with is the right hand side. That's easier to work with because we've got brackets. We can expand the brackets straight away. So no need to even think about what to do as the first step. So we'll do that. We'll expand. So we get sine squared theta times 1. That's just going to make sine squared theta. See if you can figure out what comes next. Okay, it's sine squared theta times sec squared theta. So that's going to be sine squared theta and then sec immediately followed by sec squared theta. And now, based on what you've seen already, try to guess what's the next step we're going to do here. Okay, the sine squared theta is fine. The next bit is sine squared theta. That's fine as well. The sec squared theta is exactly what we want to focus on. So sec squared theta, we know sec theta is 1 over cos theta. So we can write instead for sec squared, we can write 1 over cos squared theta. And if you're watching carefully, you'll see that we end up with something quite easy to work with. So sine squared theta times 1 over cos squared theta. Let's tidy that up. That's going to become sine squared theta on the top, cos squared theta on the bottom. And now think about that. You've seen sine over cos before. Sine over cos. This is sine squared over cos squared, but you've definitely seen sine over cos before. Sine over cos is equal to tan. Hopefully you're just about to write that. Good. So we can write that as tan squared theta now. Okay, looking good. So now take a quick peek at where we're trying to get to. We're trying to get to sec squared theta minus cos squared theta. Looks like we're quite far away. Sine squared theta is not mentioned in the answer. Tan squared theta is not mentioned in the answer, but try to think of these identities here. How can we use one of these three, or maybe even two of them, to try and end up with, instead of sine squared, a minus cos squared, instead of a tan squared, a sec squared. So the first one we want to pull out is the sine squared plus cos squared identity. We can use that to substitute in for the sine squared. So let's rearrange that. That would become, instead of sine squared plus cos squared, I can rearrange that for cos squared only. Sorry, for sine squared only. That would be 1 minus cos squared. And then I can use that to substitute for my sine squared. So that can go here. So that's pretty good because now I've got minus cos squared that I wanted to get just here. Okay, what about the tan squared? What can we do there? I'm trying to end up with sec squared somehow. Okay, this is the one that's going to help us. Tan squared plus 1 is equal to sec squared. So let's resize that. And the bit that we want is, we want to rearrange for just tan squared. So that means the plus 1 has to come over, and that's going to be a minus 1. And now I can do the substitution. I can swap the tan squared for the sec squared minus 1. Okay, looking good. And then just tidy up. We've got a 1 at the beginning and then a minus 1 at the end, so they can cancel. And then I've got minus cos squared theta. I can bring that to the end and then get rid of the plus at the beginning. And that's my answer, sec squared theta minus cos squared theta. Okay, sorry, I think I said that was the final one, but no, there's one more before you get to do some of your own. So this one, it's back to an equation. So this one is a little bit tough, but just see how you manage to, whether you manage to follow it. So it's an example, so you don't have to think too much. I'll be showing you how to do it exactly the easiest way, inshallah. So we've got to solve this for theta in the range 0 to 360. So let's take a look. We've got cosec and we've got cot. We probably want to use the identity we had for cosec and use that straight away. So we know cosec can be replaced with 1 plus cot squared. So let's do that first. We're going to replace this bit here with 1 plus cot squared. And if you like quadratics, you'll like this question because you'll see in a second what happens. So we've got brackets here, we can expand. So let's expand that out. 4 times 1 is 4, plus 4 cot squared. Then we've got the minus 9. And now we just want to try and collect everything to one side and make it equal to 0, and preferably use a little substitution, which I'll show you in a second. But let's get everything to the left-hand side. So the 4 and the minus 9, we can simplify that straight away. That's going to be minus 5. And then the cot theta, we can bring that over. And that'll be a minus cot theta. And that's all equal to 0. So this is a quadratic. It's just because of the cot theta being there, it's hard to spot that it's a quadratic. So just to make it easier, we can replace the cot with just the letter c. So we've got 4c squared, take away c, take away 5 is equal to 0. And then you can solve that any way you like. You can type that straight into your calculator. If you know how to do that now. Or you can just factorize, which is what I'll do here. So I'll end up with 4c minus 5 in one bracket, c plus 1 in the other bracket, which means my two answers for c, one of them is 5 over 4, or 1.25, and the other one is minus 1. Here you remember that c really means cot theta, so we can write cot theta is equal to 1.25, or cot theta is equal to minus 1. And then over to you if you want to type that into your calculator. Inverse, oh, sorry, one more step. We can't type that into our calculator because there's no cot button. So we need to just remember what we learned, the basics we learned at the beginning. So cot theta can be replaced with 1 over tan. So I'll have 1 over tan theta do a bit of rearranging. We can take the 1.25 to this side, the tan theta to this side. So I'll have tan theta is equal to 1 over 1.25. On this side, it'll just be tan theta is equal to minus 1 over minus 1, which is just minus 1. Okay, now you can type that into your calculator. We want to inverse tan the minus 1, inverse tan the 1 over 1.25, and then just tell me what you get. Okay, a few more seconds. Okay, well done. Excellent for the first one. So theta on the left is equal to 38.659. Remember, that's just our first answer. Can you remember how to get any further answers? So it's 38.659 as the first answer. That's true, but there's more answers. How do we get the next answer on a tan? On the on the right hand side, minus 1, inverse tan the minus 1. Let's see what you've got. Okay, good, minus 45. Again, that's the first answer when you inverse tan. But how do you get the next one? Normally it is add 360, but that's only for sine and cosine graphs. And the 360, take away the first answer, that's for the cosine graph. For the tan, it's exactly what Mu'mina said. Well done, Mu'mina. It's add 180. So if you just take each answer and add 180, and then keep adding 180 until you're out of the range required by the question, write down what you get. Remember in the exam you'd round to 3 significant figures, but I'm just going to put more here just so you can see you've got the right answer or not. Okay, good. Let's see if you managed to catch the key bits in that question. So let's take it back to here. We've got our quadratic, we've solved our quadratic, we figured out that cot theta is equal to minus 1 or 1.25, and then comes the key bit. How do we then solve it from there? Do you remember? Type it in if you remember. Okay, it's the main learning point of the whole lesson is the cot theta, sec theta, and cosec theta. They're really just the reciprocals of sine, cos, and tan. So we can replace cot theta as 1 over tan in both cases, and then just do a bit of rearranging to get it in terms of to get a number for tan theta. So tan theta is 1 over 1.25, or tan theta is equal to -1. And that's what can go in your calculator. Inverse tan both of those, you'll get your first answer, and then add 180 to get the remaining answers. Adding 180 only works for tan. For sine and cos, you have to keep adding 360 degrees. Good. Okay, the good news is that most of the hard bits in this chapter you've now covered, so you're really in a good position. But just make sure that the knowledge is there. Just see if you can do these practice questions I'm about to write. And these ones will probably take you a little bit of time. So you've got at least 10 minutes. See if you can answer the following 2 questions, just to check whether you've understood this section. Okay, first question is simplify. 1 plus tan and this one is tan squared of half theta. See if you can do that. And if you manage to do that, try the next question, which is prove is prove sec theta to the power 4 minus tan theta to the power 4 is equal to sec squared theta plus tan squared theta. And just a third one to finish it off is solve sec squared theta equals 3. And that's in the range 0 to 360. Okay, I'll give you 10 minutes to see how much of those you can do, and then we'll go through answers, inshallah. If the Zoom meeting times out in between, then just log straight back in. I just forgot the plus sign there. That's in now. Scrolling up now. Just notice I didn't write the last question correct. Okay, that's going to make a big difference. So if you've already started writing that, then apologies, but that's the proper question. And the time is going to run out, so just in a few more seconds, I'll restart the meeting. Okay, I'll just give you one more minute to see if you're getting the right answer so far. Okay, just let me know how you got on. If you got a little bit stuck, then please write question number 1 and put red. Question number 2, if you got stuck, put red. And question number 3, if you got stuck, put red. If you're happy with all of them, or whichever ones you're happy with, put question 1 green, question 2 green, question 3 green. So just stuck on the last one. Well done to Aisha. So I'll give you the answers for the first two. Just check if there's any more on that. Okay. Okay, first one, the answer is sec. The answer simplifies to sec squared half theta. Hopefully you got that right, inshallah. The last one, you got the answer there. You should end up with sec squared theta plus tan squared theta. You have to use difference of two squares to factorize into two brackets. And then the identity we had for sec squared should help you, and that should cancel it down. And you should end up with just that. So just the last one, let me just go through that in a bit more detail. So here you've got sec squared on one side, tan on the other. Sec squared is 1 over cos squared, but it's more helpful to use this one because sec squared can be replaced with tan squared plus 1. And since we've already got tan here, then that will fit quite nicely because everything will be to do with tan. So let's replace sec squared for 1 plus tan squared theta. The 3 tan theta can stay as it is. Any idea what to do from here? When you spot the same trig ratios being used, but one of them is squared and the other one's just normal, you got to be thinking quadratic equations. If you're thinking quadratic equations, you got to make one side very special. Good, rearrange to a quadratic, so that means one side has to be equal to 0. So let's do that. Firstly, the tan squared plus 1 would be better because then tan squared is the highest power, so that is better for that to be first. The plus 1 can come at the end of the quadratic, which means we can nicely slot the 3 tan theta in between as a minus 3 tan theta. and that's all equal to 0. So now you've got it as a quadratic, you then just have to solve it. Best to get a calculator that can solve it for you. Just to make it a bit easier, let's swap the tan square for just t. So I've got t squared minus 3t plus 1 equals 0. That's just easier to look at, easier to handle. But whichever way you solve it, you can't really factorize this one. You have to use quadratic formula or just type it into your calculator. You'll end up with the answer for t as equal to 3 plus or minus the square root of 5 all over 2. Remember, t just means tan theta, so let's bring the tan theta in. So the t just means tan theta. And the 3 plus or minus root 5, that means we can split it into two answers. So let's copy that answer and have it twice. And then one of them will keep the plus and the other one will keep the minus. So you got two answers to type into your calculator. Just inverse tan each answer separately and tell me what you get for theta. Just type in as normal. Type in exactly what you see and then inverse tan it. Okay, give you a few more seconds. Okay, good. 69.09 is one of the answers, and we do have a second answer of 20.91. Fantastic. Can't remember which way around it goes, so I'm just going to put the answers anywhere. So one answer is 20.9, and the other one is 69.09. And you have to keep going until 360. So take each answer and just add whatever if you remember what you need to add to get to the remaining, to get to the next answer. Okay, it's add 180 if you were struggling to remember on tan, just add 180. So that's good. So that gives you your final answers of, or your next couple of answers of 200.9 and 249.09. Remember in the exam, round each answer to three significant figures after you've written it down in full, just to make sure you get yourself all the marks, inshallah. Good. Well done. Take a 10-minute break and then we'll do the last section of the day, inshallah, which is actually quite an easy section, so it shouldn't be too hard at all, inshallah. Your lesson's going to restart in about 1 minute, inshallah, God willing. Okay, just a few seconds and then we'll restart, inshallah. Okay, Bismillah ar-Rahman ar-Rahim, in the name of God, the most gracious, the most merciful. Last section for the day is just to look at inverse of sine, cos, and tan, but we're going to be using a different name to what you're used to. So let's begin with what you're used to. Let's say we have in degrees, tan of 45 degrees, that would be equal to 1. Sine of 30 is equal to 0.5, and cos of 60 degrees is equal to 0.5 as well. If we forget about angles and sines and cos and tans for a minute, then we can look at something that you're really used to is square numbers. So we could say 4 squared is equal to 16. And in maths, everything has an inverse, or lots of things have an inverse. So square numbers or squaring a number, the inverse of that is the square root. How do we write that? If 4 squared is 16, we'd say the square root of 16 is equal to 4, or actually plus or minus 4. Let's think of another inverse. Let's think of, so just to recap, lots of things in maths have an, Bismillah, so just to recap, lots of things in maths have an inverse. So 4 squared is 16. Squaring has an inverse. We can write that as the square root of 16 is equal to 4. It gets us back to the beginning. So similarly, sine, cos, and tan have an inverse. They help us get back to the beginning. So if I take the inverse of tan, then and type in 1, then I'll get back to 45. The way you write that so far on your calculator, you'll see it is a little -1 on the tan. That doesn't mean power -1, it's just a way of saying the word inverse. Inverse of tan, and we'll normally put brackets around the 1 to show that that was the answer here, is equal to 45. That's one way of writing it. But the new way that you're going to write it for this chapter in A-level is we're going to use the word arc. So arc sine means the inverse sine. Arc tan would mean the inverse of tan. So instead of writing tan of tan to the -1, we would just write arc tan. And what it really means is inverse tan. So the inverse tan of 1 would get you the angle of 45. Arc tan. So let's take a look at the next one. We know that sine 30 is equal to 0.5. We can type that into a calculator just to check if we're in degrees mode. We can type in an angle of 30. We can use the sine button and we get 0.5. But how do we get back? So if I had 0.5 on my calculator, how do I get back to the 30 degrees? I'd use inverse sine. So that's written as arc sine. So arc sine of 0.5 is equal to 30. And we can just check that. Arc sine really means inverse sine, inverse sine. I think I pressed the wrong button there. 0.5 inverse sine gets you back to 30. Okay, and the last one you can do, if you can tell me cos 60 is equal to 0.5, how can I rewrite that using inverses or arcs? Okay, if you're a little bit stuck, look at the pattern. We've got 4 squared is 16, so the answer of 16 comes in the inverse function right at the beginning. So similarly, cos 60 is 0.5. We'd want the inverse function to start with the 0.5. So that's right. Arc, almost right. Good. Arc cos of 0.5 is equal to 60. Good. Okay, let's see if you can practice that a little bit. Just a couple of practice questions to finish off the chapter. If you can work out, this is in radians, so make sure your calculator is in radians mode. So the question is work out arc sine of 0.5 plus arc sine of minus 0.5. And if you're comfortable with that one, try one more. Which is sine of 2 arc sine. Okay, try those questions. Type into the chat window your answers once you're done. Make sure your calculator is in radians mode for both. Okay, hopefully that's enough time to do at least one of them. And just getting practice of typing into the answer. So the first one is 0, well done. And the second one is 1, well done. Good. Okay, and that is it. That's the last part of this whole chapter on trig identities. There was one section on graphs which I didn't cover, but if you get a graphical calculator, then you won't get stuck in the exam on any of those questions. And that's it. So now try and make sure you practice if you're going to do practice questions, then do practice. The name of the chapter is called Trigonometric Functions. And any question where it's got sec or cosec or cot in it will be good to practice. And similarly, sec squared, cosec squared, cot squared. Do take a snapshot of the things that you have to memorize which came in useful during the lesson, and just press print screen on your laptop and save that as a picture. Thanks for joining us. Assalamu alaikum wa rahmatullah. Peace be with you and the blessings of God.